Hey guys, today we are going to be solving this problem, which is given that n is a natural number which is greater than or equal to 2, prove 1 minus 1 over n plus 1 over n squared is less than 1 plus 1 over 2 squared plus 1 over 3 squared plus ... 1 over n squared. And we solved a similar problem on this channel before, and that was a little tricky. I will leave it on the top right corner if you want to go check that out. But I'm just going to explain this, how I explained the last problem that we saw. And I will be going in depth in the solution. So if you want, or if you know how to solve this problem already, then pause the video and give this problem a go. So now I'm going to go over the solution. How do we approach this problem? Well, in that previous video I was talking about, we learned an important theorem, and that stated that when k is less than or equal to x is less than equal to k plus 1, where k is a natural number, then this is also equal to 1 over k squared is less than equal to 1 over x squared, 1 over x squared is less than equal to 1 over k squared. And that's the theorem. In the previous video, we learned a little bit of a different theorem since that was a different question. And it was honestly a harder question than before. But for now, for this question, we are going to use this theorem. So when k is less than equal to x is less than equal to k plus 1, then 1 over x squared is less than equal to 1 over k squared. And you can also add this 1 plus k plus 1. So that would simply go over here. Then that is less than equal to k plus 1 squared. So that is a really important theorem you should keep in mind. But for now, we're not really going to use this k plus 1 squared. We're just going to focus on these two components. So from here, we know that 1 over x squared is less than equal to 1 over k squared from that theorem, right? Now, let's take the integral of both sides. Integral 1 over k squared is less than equal to integral 1 over x squared. Keep saying k. X squared is less than equal to integral of 1 over k squared. And this is going to be from k to k plus 1 from here. K to k plus 1. However, the inequality sign, this equal to doesn't always hold true for all the values. So we're just going to erase that since it's not true for all the values. There. Now, let's solve this. This is dx also. We are integrating it by x. This, let's just leave this as it is. We're going to solve this side first. So that's integration k to k plus 1. 1 over x squared dx is less than, we know that 1 over k squared is just a constant, right? Because we are integrating it by x, not k, and k is not x, so we can just simply treat this as a constant. So we can take that out, and we're left with the integration of k plus 1 of 1 dx. Once again, this stays the same, so we get integration k plus 1, 1 over x squared dx is less than, now this is simply k squared, k plus 1 minus k. This and this cancel, you're just left with 1 over k squared. So let's just erase that. Now, we are left with this. Let's solve the left-hand side and the right-hand side separately. So let's draw a line over here. Let's say that this is 1 and this is 2. Let's do 1 over here and 2 over here. And let me make this line longer. Now that we have this, let's see. Let's take the summation of this. And once we do, we get summation of k equals 1 to n minus 1. 1 over k squared dx, the integration, once again, k plus 1, is less than summation of k equals 1 to n minus 1 of 1 over k squared. And the reason I did this is because this summation is actually going to help us get this, because we know that they're being added on the right hand side here. They're being added. So that kind of reminds me of summation. So that's why I took the summation of both sides of the inequality, so that we can get the right hand side. Hopefully we'll get the right hand side. So we're going to use this. So this is also 1 and this is also 2. Once again, these two, this one and this one, they're both equal. Next, what I can do, I can solve 1. So let's look over here. We see that k equals 1 to n minus 1. Let's replace k for 1. So we get 1 to 2, 1 over x squared dx, plus this is when k equals 1. When k equals 2, we get integration 2 to 3, 1 over x squared dx. When we get k equals 3, we get integration 3 to 4, 1 over x squared dx. And finally, when we get k equals n minus 1, because remember there's an n minus 1 right there, we get plus integration of n minus 1 to n minus 1 plus 1, which is just n of x squared dx. We can also further simplify this. We know that we're integrating the same exact thing, which is this 1 over x squared, 1 over x squared, 1 over x squared, and 1 over x squared. So we can just condense this into 1 to n 1 over x squared dx. This is because, for example, if you have, let's say, integration 1 to 7 of x squared, you can rewrite this as 1 to 2 x squared dx plus 2 to 3 x squared dx, and then so on until you get 6 to 7 x squared dx. It's the exact same thing that I did over here, except we're using n. So now what do we do? Well, we have somewhat simplified this, right? But let's try to simplify it even more. We know we have an integral and we know how to solve integrals, so let's carry on with that. This is basically 1 to n x to the power negative 2 dx. Solving this, we get 1 over x, 1 to n. We get minus 1 over n minus 1. And we get 1 minus 1 over n. This is an important part, so we will highlight it in blue, I guess. And now we also have to solve the second one right here. Let's also do that. Let's replace k for 1. So if k equals 1, then this is 1 over 1 squared. Plus, let's replace k equals 2. Let me move this over here. We get 1 over 2 squared, which is 2 to the power 2, plus when k equals 3, we get 1 over 3 squared, plus when k equals n minus 1, because there's n minus 1 here again, we get 1 over n minus 1 squared. Okay, and now we can't really simplify this anymore, so we're just going to leave it as it is. So then this is also a key component. Then we're going to go all the way down here, and we see that we have this, which was the left-hand side, right? We solved this. This was the left-hand side. The left-hand side. And this was, oh, I circled the wrong thing. This, let me get this. This whole thing was the right-hand side. Now, we see that the right-hand side was greater than the left-hand side, so let's write this whole thing is greater than, let's say that this whole thing is greater than this thing. Let's do that. So we see that 1 minus 1 over n is less than this whole thing. So I'm just going to write that. 1 over 1 over 1 is just simply 1, so I'm just going to write 1. 1 plus 1 over 2 squared plus 1 over 3 squared, dot, 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 plus 1 over n minus 1 squared. However, as we look in the question, we see that we have a 1 minus n squared here and a 1 over n squared here. So we just simply have to add 1 over n squared to both sides. So we get 1 minus 1 over n plus 1 over n squared is less than all of this plus 1 over 2 squared plus 1 over 3 squared plus dot, 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 1 over n minus 1 squared plus 1 over n squared. And we basically proved this. We know there is not a 1 over n minus 1 squared in the original problem, as we saw over here, but technically it's the exact same thing because this is n squared. The term before it is going to be n minus 1. The term before that is going to be n minus 2. So essentially we proved, we proved that 1 minus 1 over n plus 1 over n squared is less than 1 plus 1 over 2 squared plus 1 over 3 squared plus dot, 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 1 over n squared.